Thank you, Ramesh.
So the very important question, right, for us to understand why Java? Yeah, I mean, basically, why was this made? There's so many languages, right? Um, your English as a language, your Kannada as a language, and so many languages. And why did they make this language? Of course, it is a computer language. Computer understands this language, but then Java in particular is not the level what machine understands it, right? Java Java has its own syntax, like your English has its syntax, Java has its syntax. Now you don't say great is God, right? You'll always say God is great, right? So that's a syntax. You follow that syntax when you're doing English. We have been taught on a certain syntax of English. Likewise, Java also has a syntax. Yeah, somebody who made this, they they did it in a certain way, right? There are rules in English. Also, there are rules in Kannada. Also, there are rules. Yeah, so it's that kind of language. So Java in particular is slightly little different, right? So yeah, there is a well-known thing called object orientation, right? It's called object-oriented technology. So we'll try to understand through this. Yeah, they also call it as object-oriented program, or they call it as OOPS, right? Very famous. So what made them to think like this? So before Java, the computer as a language or software as an industry or computation as a field, yeah, the machine computation, it all started with the simple calculators. Calculators are still a more advanced gadgets. But before calculators in 1950s, even if we had to do a small addition, if machine had to perform a small addition, 1 plus 1 is equal to 2, big machines were used, yeah, in 1950s and all. So we'll not go back to that history, but then it is more relevant of why Java came in, right? So when they were doing that from 1950s, when the technology was evolving, the hardware industries was evolving, the electronics as a field, right, was evolving. Along with that, then the software is also evolving. Your hardware as in what which can perform at the back end, right? So what is your hardware? It is always that magnetic signal. We shall go into the depth of it sometime later, but then at a very high level. So your machine does not even understand ones and zeros, right? This is still a encoded version. This is understood by us. Machine does not understand. Machine once again, your one corresponds to on and your zero corresponds to an off. At your hardware level, at your microprocessor level, the gates, they still see it as an electric signal. Yeah, that is how it is computed. We understand it as one and zero, but then machine understands that. But then if we had to do the programming on one zeros, humanly it is impossible. Hence they made a language, C, C++, and then Java, right? So once again, what the language is there with certain instruction syntax, that language, what you are writing, okay, the program, what you are writing, the language, what you are writing, is once again converted into a byte code or a binary code, which is into one zeros, it is converted. Yeah. So, and then there is something called machine level language. Okay, so machine does not understand what you have written, right? That all gets converted into these OR gates and all, right? I'm not an electronics expert, but then eventually it gets into that. So it is called assembly level language. Yeah. So there the at a machine level, they have certain functions. All of this gets converted into simple gates, and it becomes move function, add function, yeah, all that. Eventually, and machine then gives it back to you. You give it back, and you see your output. So lot of programming. So why am I telling you? So Java is not the only thing, right? So there is somebody who has written a compiler who is checking. Okay, it's like your teacher, right? You're writing something grammatically, and then you're writing something grammatically wrong. Either your parents check whether your grammar, or your teachers check grammar, that becomes your compiler, and that gets converted into a certain thing, and then it goes to machine, and machine does its own thing. So why am I telling all this? Because let us not have that fear of, oh, Java, it's so difficult. No, the people, it has advanced a lot, right? As such, they have made it very, 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 very easy for us. We are writing it in a more human friendly way. So I want you all to think in a human friendly way. The syntax, what has been written, given to you, is a more human way. So half of the Java you could learn by learning the literal meanings of those words, what they have given. Yeah. And then it becomes very, very easy for you. Yeah, instead of getting stuck with, oh, Java is very difficult, I can't understand the syntax. No, it's not that. Somebody who would have invented this, somebody who made this, they would have given a right name, a logical name. They would have not just kept the names for the sake of keeping the names, right? They would have given a very right names. And if you think in a different perspective of why somebody would have done it that way, it gives you more meaning, and then it helps you to keep into your memory for a longer time. All right. So now let's come to, I will stop in between wherever I feel it is more logical to stop. So this was a little bit of basics, but then why Java? Earlier those days in 1980s and all, when C came in, it was called, I'm not sure what it was called. I assume it was called procedural language. What used to happen is you write a lot of code like this, straight lines. Okay, file 1, file 2. You could have many files though. You would write certain function here. Okay, you could call that file name and function. Okay, you would have written function 1 here, you would have written function 2 here. You could call them here. Okay. And then your main, let us assume your main function was here, and you could, in the main function, you could call. So they called it as a procedural language, mostly the procedures, right? Procedure as in a step. There is a certain steps and procedure, the way the program is executed or control. It starts from here, in between this is called, this gives back the control, and then next procedure, next steps happens, and then you give it, and then it gives it. Okay. So so that is how the C was. Or any other, Fortran, and there were many other languages also, Pascal and all those days. But then the way the IT world started evolving. The IT as a technology was adapted so fast after 1980s. Everybody started seeing it. So you had an UI, which was a presentation, and you had a database mostly, right, where your data was stored. So all that what was happening in paper earlier, now was all getting converted into a software. So it was a soft copy. Everything was becoming soft instead of hard copy. So, and then with the invention of internet, you could move the data across internet. That gave a boon to it. In between you got the internet, and then IT was started adapting, right? That is why you had a big boom, where literally every application, every data, the goal of the world is now that they do not want to really be on any hard copy, right? Limited usage of it, and everything they want to make it digital. Yeah. So so with that, a lot of things came in. You go to, in your college, you would have taken a sign of all the departments, right? That's a process. Like that, the workflows, and there's so many applications which we will talk later. but but then C as a procedure language, this was the language. So then what made them to invent Java? So that is what we're trying to understand. So with procedure language, the problem was you could write. Now also there are C programs. Lot and lot of backend softwares are written on C. Lot and lot of products are written in C. But the challenge with that is, the way you write the code, right? You will write some 2000 line of code. Okay. And if you had to debug that code, only you could understand. Yeah, because it was written procedurally, it was written so sequentially, right? And and the way you would write it, it would not help you to evolve in terms of your idea. So whenever you are writing a project or you're doing a project, there would it all starts with an idea, right? Somebody is doing a business and they come up with a fresh idea, and that idea they want to convert, it's an be it an Ola, be it a Facebook. Yeah, these are all wonderful ideas, right? WhatsApp. Okay, so people are inventing these ideas, and then how to make your life easier, community life easier, right, for mankind. And then when these ideas come in, they want to this is an idea, and now this has to be easily converted into a program, right? So what generally what people do is, they start with a program. Okay, and then with the program they will try to get to an idea, which is a bad idea, right? If you are a true real visionary person, and if your thought process is really good, what you would do is you will always bank in an idea. Okay, and for this idea you will see how a technology will nurture to make your idea as a possibility, right? So when I say technology, so what programming I can do, or what tools I have, this is just a tool. Java is just a tool. Okay, and then what can we do to make it happen? So that was the stage, right? So then C was the only technology, but then for people to really make their dream realize, they wanted certain technology, right? And they could do it really fast and easier. So these are the tools, how the world has been shaped up. So right from your ancient days, if you see how the world shapes up, mostly it is a tool driven. If you see anything in and around you, it is all tools what you see. Because human brain is like that, right? They will give you the necessary tools to make it. So why am I saying this? Because you as an IT person, you should always think from that perspective. Learning technology is not important. You should think from a perspective that, okay, something is given to me, how can I use it? Right? Java is given to me, how can I use it? I cannot have the fear that, oh, it has a coding, I shouldn't be doing it, it's very difficult and all. So anything in and around you is a tool. Unless you know it, it becomes really difficult. So that is why we are here to understand the Java technology. Okay, so I want to help you to change your perspective, remove that fear in you, saying that, oh, Java is very difficult and we can't really, when I read it, I don't understand. I want to bring, break that fear among you. So now, so then when they were doing the C and all, it was so difficult for them, right? So because it was not easy for the developers to really convert their idea into a program. So that is when at certain stage they realized that they should make a technology which was more object oriented. So we'll try to understand what is an object oriented. So anything, everything, right? If you see around, what do I see around me? I see a light board, right? Switchboard. Okay, there's so many switches, right? So I see a wire. Yeah. So I see a switchboard. So this switchboard, how will I write a Java program? So what are the entities? I first decide, what all I can do. So I could see a switchboard as a whole. Okay, I could see buttons. Yeah, I could see socket. Yeah, I could see at a very high level. I will see what else. Yeah, maybe three entities, right? Switchboard, and this switchboard has a buttons, and it also has a socket, right? And then switchboard itself, I will make switchboard itself as a class, maybe a super class. And then this switchboard has what it has, its own characteristics. Okay, it has a color, it has a shape, it has a quality, right? And it will do some function. We really don't know. Yeah, switchboard is meant for switching, right? On and off, it does a function. So button also I will make it as a class. Okay, and this class, okay, has, once again, this also has its color, this also has a shape, this also has a quality, it also has its own function. It does certain function. Likewise, socket will do the few things, and this button may do something else also. So not necessarily the attributes have to be same, right? This, okay. So anything, everything around you, you take any example. You can take an example of living thing, right? Any living thing, non-living thing. That is what you see around you, right? Non-living thing, right? You can see a process, some rules, right, which government have decided. Your family may have a rules, dining rules. If somebody comes and sits on the dining table, you want to put certain rules that they have to be tidy, they have to wear this dress, etc. The plate has to be positioned this way, that way, whatever rules, the process. Okay, if there is a business or if there is an institution, okay, anything you could imagine around you in your life, everything could be structured in a certain way. So that is what we are trying to understand. So in this case of your switchboard, right? So what we are trying to do is, a switchboard as a switchboard, we can write it as a class, class switchboard. Okay. So I wrote a class. So why did I use a term called class? Very simple. Class is nothing but a classification. So I classified it, right? I could have written your switchboard, your button, and your socket as one thing, but no, intentionally I decided to make them as three. You could have decided to make, you can easily write all of them into the same class. If you do not really want to do it as a three separate classes, or you may further break them into 5 classes. Okay, it is up to you how you want to do it. Okay, so that is the classification, or let me take another example so that it becomes clear to you. So let us take your own company's example, right? So you have a company and you have been told to write an HR application for the company. So first what you will do, you will design that application, right? Anything, you will put it on a table, right? So you're asked to do an HR portal, okay, for your company. So what you will do, you will first write the entities of this HR. So what are your entities? HR is one entity. Yeah, your employees are one entity, right? So your IT department is one entity, your finance department is one entity, yeah, your security is one entity. Okay, so your employees may fall into all these departments, right? You agree? Application, yeah. So HR is also a kind of employees. So they are all these employees. So HR is a process. What do you want HR as a process? HR as a process, what they will do? You want to make a timesheet, right? They want to do an onboarding when the employees come. They want to do the exit. They want to regularly talk, what do appraisal. Okay, they want to do fun at work. They want to hear employees' emotions. They want to check employees' well-being. Yeah, so many things, right? You think about it and you'll have a lot of entities. Now these are your entities. So now you can mix and match. It is up to the designers, right? Java is a flexible language where it helps you to do classify it in any way you want to write. So all of these you can make the classes. Okay, and then you can build your application. So each one of these entities will have its own characteristics and will have its own behavior. Behavior is nothing but a function. Characteristics is what it will have. So each of other employees will have their own timesheet, right? So it will vary. Yeah, function, it will do certain function. So and now when you're, it doesn't limit just here, right? So I just wrote the entities, the objects, all of them. What you are seeing are the objects in and around you, right, when you're designing it. But then when I'm writing my application, Java application itself, for me to write the Java application itself, I may want a lot of classes. I want some util class. Java has made you the string class. Java has given you the list class for you to write the Java code itself. Okay, so they have given you a lot of classes. These are what you could call them as an operational classes or a technical classes for you to do it. So JDBC, they have written the classes and already given you are not doing anything, right? JDBC gives you the result set, right, which we'll see it in a while. So they are already giving you a Java class, yeah, so which which has a method and you're using it. We'll see it in a while. And when you are writing an applications, you want to write so many methods where your util class can have a sum function, multiply function, like, so this all what which are already written, you call it as a library, because when you go to library, there is something already available, there is a something knowledge is already available, it is written in a form of book. Here it is written in a form of a class, you call the methods and you use it. Yeah, and but there is a way how you use it. Yeah, so this is for your own usage. Java has already written a lot of classes and have given it to you. You just have to understand. First, you need to understand what class it is, which class it belongs to. Then you understand what methods it is offering, methods or functions it is giving, and to that method, what input it is expecting you to send an output. And with when you send an input, what output it is going to give you. You will use that output and you will further proceed. Okay. So this is how the language has been made. Everything is a service oriented industry. Everything these days is a service, right? Swiggy comes, you order food on service, Swiggy, and they take money and they give you the service of delivering food at your doorstep. So you gave an input as a food, and then they gave you the food, sorry, input as a money, and they give you as a food. Everything is a service oriented architecture. So this is what it is. This is what is called object orientation. Everything around you, you are seeing. You throw an object, you think of anything, everything around you in your life as an object. And then things will become very simple. Okay, I will stop here for questions, and then we shall continue.